Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Welcome to the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host today. Today on the show, what I want to talk about with everyone is the question, how do we confidently call the failure of a control module within the automotive realm? And this really covers any control module on the vehicle. And, we're seeing so many of them on vehicles nowadays. It's more and more common to have 10, 15 plus modules on a single vehicle than it used to be. I mean, we go back, at least when I started out in this field, we had an engine computer, an ABS computer, and an airbag control module, and then maybe a BCM. And that was pretty much it for the most part, unless you were working on some high-end luxury vehicles. But nowadays, I can't think of a vehicle that has that few modules on it. And so we're seeing lots and lots of control modules on these vehicles. Well, of course, that increases the odds that one of those modules is going to fail in some way. And that does happen. I go out to a lot of shops and I program in these new control modules and they are failed and it fixes the problem. But there's also a lot of times, and I've been seeing it a lot recently, where the control module is not the problem. And I mean, to be quite honest, there is a large portion of the time where I leave the shop with the old control module plugged back in because the new one, wasn't going to fix it or didn't fix the problem. And so what this episode is about is kind of based off of that fact that I see a lot of control modules replaced unnecessarily for various reasons, but usually because the diagnostic either wasn't done or wasn't done correctly. So I'm going to go through some different ways that we can be confident in our call of saying that module has failed in one way or another. And, sometimes it's easy, other times not so easy, but we can use some different things and acquire some knowledge about the systems that are going to help us, again, be confident in that call that when we replace that control module, it's going to fix the problem. And being confident in that is important because these control modules, a lot of the time, are not cheap. There's plenty of them that are at least $1,000. Some of them are going to be cheaper. It depends on the module and the brand and the age of the vehicle. But some of these are very expensive. Plus, even to get the module in the vehicle and just to see, does this fix the problem, you've got to program it to that vehicle, which if you don't have the equipment, you're either sending it to the dealer or calling in a mobile programmer, which is an added expense. But then on top of that, the control module is now tied to that vehicle. You own it. You can't return that control module if you program it to that vehicle. That VIN is locked in there. A lot of these are one-time use. You look at GM Global A vehicles, and for the most part, they're one-time right for the VIN, and you own that module once you put it in. So then if you didn't make the diagnosis correct, well, now you have a module that you replaced unnecessarily, but it's going to go in that car, and somebody's got to eat the cost of that module. And, that presents, I'm sure many of you are aware of this, but an issue where we can't just swap in a known good module on a lot of these vehicles just to see if it'll fix the problem. That used to be the case, and if you had availability to a known good module, maybe you worked at a dealership, you could grab an ABS module off of this car, put it on the other one, see if it fixes the problem. You can't even do that nowadays on a lot of vehicles because we run into things, again, picking on GM with their Global A structure. If you put in one of these modules, it can actually set environmental security codes in other modules that you may not be able to erase after the fact. So not only will it not work, but you could cause more damage by swapping around modules. 2013 and up, don't swap around modules on GM. Maybe that's the thing to go with there. But anyways, what I'm getting at here is we need to be able to make a call with the existing module to say, yes, this is good, or no, this is bad. And this is what this episode is going to be about. So the first thing that we need to do here, because here's the deal, there's as many possible module failures. If we look at a unique failure, there's as many as there are control modules out there. There's so many. And number one, I don't know all the possible failures that you could experience, but we also don't have time for that in the podcast, even if I did. So I'm going to break this down into some basic categories, because the way in which the module fails does change our approach slightly. Again, there are a ton of unique circumstances, but I want to put these into three basic categories, and then we'll go through the steps that I would take for each one, and they'll overlap in some cases, but let's name those categories so we know what we're talking about. The first one, and generally this is pretty easy, but I still see people make the wrong call on this, is a completely dead module. What I mean by dead is you cannot communicate with this control module. So if you plug in your scan tool, it says no communication. Maybe there's codes in other modules that also say no communication. And the functions for that module don't work. Okay, whatever that module is in charge of, it's not doing it. Okay, if it's the engine control module, it's not cranking or not starting. It's not operating injectors, coils, whatever that module is meant to operate. It's not doing it. You can't communicate with it. I would say that is a dead module. All right. So that's number one. Number two would be a module that's not completely dead. It may actually still operate some of its functions. It may not do them all correctly, but you can't communicate with said module. And that can be the fault of a module, but there are other possibilities too. So this would be a module that I wouldn't consider completely dead, but I can't talk to it with my scan tool, and maybe other control modules can't talk to it. So that's number two, the type of failure that we might see with the control module. The final one, and this is probably where I'm going to spend most of my time here because it's the most challenging, is a module that you can communicate with. So you plug in the scan tool, you can communicate with it, other modules can communicate with it. So obviously it's coming online, it's doing its thing, controlling whatever component it's supposed to, but one or more of the functions of that module does not operate or does not operate properly. All right, and this is the category where there are thousands and thousands of possibilities here, unique scenarios that are going to have their own individual path and understanding of a specific system. But I'm putting them into one category because this can definitely be the most challenging of the three categories that I'm listing here, is where you have one function in the module that's not operating correctly. You have, this could even be something like where you have a DTC that's setting in this module that you can't find the reason for. You know, it's the fact that the module is failed, which is, again, definitely a possibility, but we need ways to confirm that. So again, just real quick, dead module number one, nothing, blank, nothing happening. A module that's not completely dead, maybe still doing some of its functions, but you can't talk to. And then finally, a module that you can communicate with, other modules can communicate with it, but one or more functions of that module is not working correctly. You know, some output, some data PID, some DTC. Again, there's a wide variety there, but that's our third category. So we're going to go through these one by one, and I'm going to explain to you how I approach it when I go into a shop trying to determine, you know, what the problem is, or is this control module actually failed? Do we need to replace it? So first off, with the dead module, these checks for a completely dead module really are going to apply to every one of our categories. And I would do all of these, or at least most of them, anytime before I completely call a control module. And there's some points where you can make an argument. You could skip a couple of these steps, but let's go through these. If I have a module I plug in, I can't talk to at all, it's not doing anything, here are the things that I'm going to check for on this control module before I can call it's actually dead. Number one, we need to check power to the module. Okay, this is pretty obvious. I get it. We're all aware we need power, we need ground, and ground, of course, is number two. I might as well include that in this because they're kind of the same. Obviously, we're checking for voltage or we're checking for a ground. Every single module needs this to operate. Okay, and this sounds simple enough, but I see it overlooked. I just had a module this week. If you listen to the tech tip, it was a chassis control module that the dealer recommended the module need to be replaced. Well, it ended up being a corroded power wire. The module can't operate without power. All right, now the notes I have here is do be aware that most control modules are going to have more than one power feed. Maybe that's not true for everything, but you need to look at the diagram and you need to make sure, are there multiple power feeds to this module? How many are there? Is it 2? Is it 3? And you need to check all of them. Same with the grounds as well. Make sure that you're not just skipping over a ground that needed to be checked and checking a different one. These modules can have multiple ground feeds, multiple power feeds. The other thing about checking powers and grounds to a control module, remember the fact that most control modules are in charge of operating some sort of output. And an output is a component on the vehicle that's designed to do some work, meaning that it's going to have to take some current. And maybe the module's not directly in charge of handling the current, but in a lot of cases it is. Just for example, an electric throttle body on an engine, the module is entirely in charge of handling that current, meaning that the module has to get that power, that current from another circuit. And that would be the power and ground feed to the module. So what I'm getting at here is we need to make sure that we are loading the powers and grounds to the control module. And you can do this a number of different ways. You could use some sort of load like a headlight bulb in place of the control module and make sure that it lights brightly. You could also have the module plugged in, attempt to operate it and either do a voltage drop or just use a meter in a way that we're checking the circuit live. I like to use a headlight bulb in most cases. If I can pull 4 or 5 amps through a wire, generally, that's going to be good enough. And I could see an argument, depending on the situation, where you might need more of a load, but that has served me pretty well. What you want to avoid here, though, is using your voltmeter on like an open circuit test. And I have a whole episode about checking circuits loaded. But even with just a regular test light, a lot of our test lights, even if it has an incandescent bulb, are only somewhere in the neighborhood of 1 to 300 milliamps. That may not be enough for that computer to do its job. And so we just have to remember, if we're going to check power and ground feeds to our module, that we should be loading those down, making sure that the circuits can actually handle the amount of current that that module requires. So power and ground, those are my two first checks. The next one kind of is included in a power, but there's some variance here depending on what you're working on, and this is the ignition, or also considered the wake-up circuit for these modules. So a lot of control modules will receive constant power and ground, and then they will also have some sort of wake-up circuit. And the module will not come online, do its thing, communicate, until it gets this wake-up signal. And I have a whole episode about going through this on a Buick Regal where I was searching for why I was having issues as far as modules coming on, setting codes, doing their thing, and it ended up being a wake-up circuit to those modules. And I've seen this on other vehicles as well, where the tech will replace a control module. They checked their basic powers and grounds, but they missed the ignition wake-up. A lot of times in GMs, this is called a serial data wake-up. If you look at the diagrams, it's not listed necessarily as an ignition feed or a switched ignition source. It just says serial data wake up. And this could be coming from another control module, but what we need to remember is certain control modules won't do anything, even if they have their main power and ground feeds, until they receive this wake up. All right, something to consider. And that wake up can be done over the CAN bus too. In that case, you don't have an individual circuit to check, but it does lead into our next thing that we need to check for these control modules is communication. And this is going to vary quite a bit depending on what you're working on. But if a module's not turning on, and obviously if you can't communicate with it, we need to figure out, how does this module communicate? Is it over one network? Is it over multiple networks? And then we need to go in and obviously check out the communication of that vehicle, see what's going on with the comm lines. If it's a CAN bus, you've got 2 wires, maybe it's a single wire. It really is going to depend on the vehicle, the brand, the configuration of the network. Lots of different ways to approach it depending on the vehicle. If you want to check out an episode I have all about communication faults, I actually do have that. The name of the episode was what we have here is failure to communicate. And I go through a case study on 3 different vehicles where we're dealing with those exact scenarios. So more details on that if you're interested in, actually testing for communication issues. Finally, for a dead module that's not communicating, not doing its job, we want to look at our 5-volt reference circuit. Now, I realize that not every single module out there has a 5-volt reference circuit that's being used for inputs generally, but a lot of them do, and there is a potential, if the 5-volt reference is shorted to ground, that it can take out a module. So we want to be aware of this. And one quick check I'll make on a lot of modules just to see, is this thing awake? Is it doing anything? Is actually check for a 5-volt reference. And if I see that 5-volt reference and I can't communicate with the module, of course I'm going for the network in that case. But if I see that there's no 5-volt reference on any of the inputs that should be there with the key on, I need to ask myself, is there no 5-volt reference because the PCM's not putting it out because it's dead? Or is there no 5-volt reference because it's shorted to ground somehow? And we can use a test light usually in this case to figure that out, because if it's shorted to ground, it's going to light a test light that's connected to power. If it is, just no 5-volt reference, then that's obviously not going to happen. So that's a quick check that you can make. But just keep in mind, shorted 5-volt reference can cause a lot of problems. It doesn't always knock out the control module completely, but I have seen scenarios where that does happen. So it is one thing that you should definitely check before you replace a control module, see what is the status of the 5-volt reference. And also keep in mind, control modules, especially newer ones, can have multiple 5-volt reference circuits, so that can change things as well. But always something you want to consider before finally replacing a control module. So that covers my completely dead module and the checks I'm going to do. I'll go through those again real quick here. That is power, ground, ignition or wake up, communication, and 5-volt reference. All right. And again, these things that I'm checking here will actually overlap into some of the other categories that we talk about, but those are important checks that we need to make. All right. The next one that I want to cover is just communication failure with a single module, and probably won't spend a whole lot of time on this, but because I kind of talked about it already in the dead module, but I just want to set up the scenario for you here and explain what you would encounter if you were to connect to this vehicle. So you plug in your scan tool, and let's say it's an engine control module, and you cannot communicate with this engine control module. And there are other control modules on that network that also can't communicate with it. So there's codes setting for no communication with the ECM. But maybe this engine cranks. It might not in a lot of cases, depending on the vehicle, but maybe you have a 5-volt reference present. Okay, that would be an instance where you see, okay, there's a 5-volt reference, meaning that module's awake, it's doing something, but I can't communicate with it. And this is a case where you want to zero in on your communication. That's going to involve figuring out the network configuration and testing at the module to see, is it connected to the network? Is there a break in our network somewhere? And this is one thing that I wanted to bring up about actually testing at the module. And really this applies to more than just the communication side of things, but we need to verify at the control module that the connector integrity is what it needs to be. What I mean by that is we've got large connectors going into these control modules, and quite often they have some sort of plastic lever that is going to lock them into place. You could call this a connector assurance. I call it the lever. It's just a plastic lever that you're going to swing. It's going to move some part of that connector to not only lock it in place, but to push all the male and the female pins together to make sure that this connector is actually like latched on to said connector. And what we can experience, and again, this doesn't necessarily always pertain to just communication, but since we're at the module, we want to check for communication, make sure the network's good to that module. This is one of the things that we want to look for, is that this connector is doing its job properly, that there's no plastic that's broken, there's nothing that's obstructing this connector, the lever's swinging the way it's supposed to, the weather packing isn't jammed up inside of here, that it's actually sliding how it needs to in order to make contact with the module. And I just ran into this recently actually on a Pontiac G5 where the lever for the PCM connector would move, but the actual slides that pushed the connector down and locked it in place weren't moving. And so although it looked like this thing was plugged in, you had another 1/8 of an inch that you needed to push this connector down in order for the pins to make contact. And the PCM did not have the circuitry that it needed for communication without this lever doing what it was supposed to. So what I'm getting at here is when you're at the module and you're looking at these connectors, verify that nothing's broken, that they're actually being latched down properly, they're making proper contact. Now here's the other thing that you want to do at the same time when you're at the module. You're doing tests on the network to see, is this thing connected to the network? Make sure to check pin fit as well. And this is something where I run into where control modules are replaced quite often when there is a pin fit issue. And this would be a female terminal that has expanded, gotten stretched out, and the male pin is not making proper contact. And this could be intermittent, maybe it's not, but we want to do a pin drag test. One of the first episodes of the podcast covered pin fit in pretty good detail, so check that out if you want some more details there. But to sum up this category of failure, again, this is communication, and I expanded a little bit on it, but really what we want to do is we want to go to that module and make sure that it's connected to the network. For more details on network testing, again, check out what we have here is a failure to communicate episode. Lots more details on there on tools and testing for network problems. All right, so for our third and final category, this would be, I definitely consider the most challenging problem to be confident in our call, that we're going to have to put the most amount of thought and research and work into making the right call here and not overlooking something. And it's really going to depend on the unique scenario and the vehicle that you're working on as far as what exactly that you do. But I'm going to, again, break this down into some basic categories of the things that I see on a regular basis and the things that you want to consider before you replace a module. Again, this third category is a module that you can communicate with. You can talk to it with the scan tool, but one or more functions of that module doesn't work, or maybe doesn't work properly. Or this could be a DTC that's setting, and you don't really have any explanation for why it's setting. Maybe it's a control module. Maybe it needs to be programmed. That's what I get called for a lot is, hey, can you reprogram this control module? It's doing this thing that we don't want it to do. I'm like, I can. I don't know if it'll fix it. And let me tell you, most of the time it doesn't fix it, or there is no option to reprogram said control module. So this is, again, the area where this can be the most challenging, and techs often just get to the point where like, well, we got to replace the control module, or we got to reprogram the control module. We have no other ideas on where to go. But I think we can do better. I think we can really dig into this and be confident in what we're doing, even if that is replacing a module or going after the actual problem in some cases. So let's break down some of the things that can cause this. I'm going to give you some examples as we go, so this makes a little bit more sense. The first thing is an input that has failed. And if you think of a computer in the simplest sense, it is just an input that feeds a processor that operates an output. Okay, input, process, output. That's basic computer operation. Of course, I'm simplifying things quite a bit, but I like to think of things in their simplest sense. And for me, it is exactly that: input, process, output. And we could have an input failure or an input circuit failure, but some of the data that the computer receives is faulty, and it's going to react based on that faulty input and maybe do something on an output side that's incorrect, but it was because of the incorrect data that it got fed in, the incorrect input. So not really the fault of the computer that it's getting bad information. We need to be able to identify this. All right, so here's an example. And again, I'm going to reference some of the case studies that I've covered in the past. If you go back to an episode where I covered a 2007 Dodge Nitro, the name of the episode was Never Ever Worked. It's about new parts that can be bad. We had some O2 sensors in this vehicle, and these O2 sensors were brand new, all four of them. But we had all kinds of heater circuit and O2 sensor codes that were setting. And the reason was, even though these sensors were new, the heater circuits in these particular sensors were not correct for that PCM. And so the PCM didn't know what to do with it. And I guess you could consider that on the output side now that I'm saying it out loud, because an O2 sensor is an input and an output, but the sensor itself was not working. The actual voltage producing part of the O2 sensor wasn't working because it wasn't being heated properly, because the computer wasn't operating the heaters, because they, were not the correct amperage, not the correct resistance for that circuit. Basically, we had a sensor that made it look like the PCM had no idea what was going on, was doing the complete wrong thing, but we needed to get the correct sensor in there. And again, I guess that O2, now that I'm saying it out loud, really involves an input and an output, and the output portion was maybe the failure in that case, but that's okay. That'll transition us into the next section here. Of course, there's a whole lot more inputs that the computer gets fed, but again, that data needs to be incorrect, and the circuit and the sensor all needs to be doing the correct thing in order for all of this to happen. So again, on that O2 sensor note, let's move to the next one, which is an output failure, okay? And that Dodge Nitro was kind of an example of that, but just another one off the top of my head. General Motors 3.8 liter in a Chevy Impala had a shop that replaced an EGR valve. And this is a pretty simple setup. It's just a 2-wire solenoid with a potentiometer. Well, it was set in a code, and it was not actually activating the solenoid portion of the EGR. And the shop was concerned that this was the computer's fault because the one that they had replaced was also an issue. Well, it turns out somehow or another they had gotten the incorrect EGR valve for this vehicle, and the amperage draw for that solenoid in that EGR valve was incorrect for the computer on the new part. The computer saw this, shut down the circuit, and even though there was a code, they were perceiving the computer to be at fault because it wasn't controlling the circuit. It just stopped doing it. And again, I have a whole episode on intentional circuit shutdown, but we can see this in outputs a lot of the time where the computer's looking at the amperage draw, and if it decides it is not within the right range, too low or too high, it can shut down that circuit. And it could look like the driver has failed for that particular output when really it's the fact that that output, maybe the circuit has something wrong with it or the output has something wrong with it, and it's caused that circuit to shut down. And the PCM is designed to do that. It's doing what it's supposed to. You could replace the PCM, it's going to do the exact same thing. So we got to be cautious of that. Of course, we could have an output that's just doing the wrong thing. Maybe the PCM is operating it, but that particular output is just failed. And we need to find different ways to evaluate that depending on the specific output, but something we want to be aware of as well. One other note I wanted to make here as we're talking about outputs is don't forget about the mechanical components themselves. And one example here is I was recently dealing with a Ford, it's a Focus, and it had the automatically shifted manual transmission. And I seem to be doing TCMs in these things several times a week, lots and lots of failures out of these transmissions. Well, the shop had put a TCM in this Focus, and it was having problems with some of the clutch motors working the way they were supposed to. And a couple of the motors are built into the TCM, a couple of them are external. Well, after replacing the TCM, they still had the same problem. And they went through it, and they actually replaced a couple of the other motors on the transmission as well, the electric motors that move the clutches, and still had the same problem. And we still, we're encountering the same codes and the same issue with the new TCM and the new motor. And it ended up being internal to the transmission is where I'm getting at with this, is there was a mechanical problem within the transmission that were causing codes in this TCM to set, making it look like it's the TCM or it's the output. But really, there are, at the end of the line, there's some mechanical component that we're dealing with. So don't forget about that to check the actual component that's moving, that's doing something to make sure that it's actually happening. All right. The next category of faults, this one can be extremely challenging, especially if it's something that you're running into for the first time or a vehicle that you're not familiar with. And this is when you have another module on a network. Okay, so let's say I'm dealing with the ABS control module, and that ABS control module is on a network with many other control modules. And let's say this is on a 2008 Chrysler Town & Country, because it is. This is one I dealt with. There's a TIPM, or totally integrated power control module. It's the fuse box under the hood, but it also controls a lot of circuits, and it's on the network. It talks. It's a control module. And this ABS module is setting some codes for vehicle speed. And if you go into the ABS control module and you look at the data PID for vehicle speed, that you see that it is at 318 miles per hour all the time. The vehicle's in park. It's listing in the ABS module 318 miles an hour. Well, it turns out in this vehicle that there was nothing wrong with the ABS module. There was nothing wrong with the wheel speed sensors in this vehicle. The problem was somebody put a used TIPM in this Chrysler Town & Country at some point or another. And this used TIPM was not configured properly to this van. It was out of a different year or a different model. And the ABS communication that happens with the TIPM, it didn't like something about that. It was very unhappy about the data it was receiving and giving a wild value in the data PIDs. And you could easily mistake this as an ABS fault, and you could replace that ABS control module or wheel speed sensors and you'd never change it. It would still list the wrong thing until you address this used TIPM. And again, this can be really, really challenging, but we gotta be aware that modules will use other modules on the network for their information, for their inputs, for data. And if it's not getting that from a different module, The module that you're looking at could be doing something incorrectly, could be setting a code, could have some value in the data stream that just looks really weird, but we got to consider, where is this module getting its information from in regards to what's happening? Is it sharing a sensor with another module somewhere? Is there some clear interaction between two different control modules? For another simple example is an engine that won't crank, and the ECM is in charge of the starter relay and cranking the engine, and it's not cranking. But the reason is the TCM is down and it's not feeding the park reverse drive neutral switch or input into the ECM, so it's never going to crank. Just another example of sharing data, and we got to be aware that there could be other modules on that network that could be causing the issue. And the other thing that this brings up as well, which is the next category, is the fact that the module you're dealing with could just be wrong for that vehicle. All right. And this is where you want to get the history. Obviously, if you put it in, you're going to know if you swapped out modules. But a lot of times I get vehicles where nobody told me that they swapped in a used module or a new module or whatever it might be. And it's very possible it could be the wrong one for that vehicle, or it could be programmed incorrectly for that vehicle. And this could cause a whole host of problems, but it is something that you want to be aware of. And the best way to be on top of this is to ask your customer or whoever you're dealing with, the history of the vehicle. What have they done recently? Have any of these modules been replaced at any point? And sometimes you don't get all the answers you're looking for. There's other ways to go about figuring that out, checking the VIN and the modules and the software level and stuff like that. But asking questions up front can really save you there quite a bit. Finally, one more thing that you don't want to forget about, and I bring this up because I tend to forget about this a lot. I don't always check for this, is that our alternator can actually output some AC voltage, some ripple out into the electrical system of the vehicle. And this can happen at specific RPMs or under certain loads, but don't forget to check your system for some AC voltage, for some ripple, because that can cause some weird control module issues. And again, for whatever reason, I always seem to forget about this until the very last thing. I'm like, oh shoot, I should check for that and see what's going on, because there's not necessarily codes to set all the time for when that happens, and it might be something that you could overlook. So to sum all of this up, the main point of today is, let's be thorough before we call a control module, before we say that's it. It's easy to do because most of us can't just go inside of the control module and start diagnosing individual things. Sometimes it does happen, and some people are really good at that sort of thing. But a lot of times what I see in general shops is technicians get to the computer. It's a mystery as to what's inside. We don't know what's going on. Let's just replace it and see what happens. And so much of the time, it's unnecessary. Again, more common nowadays that we've got so many control modules, but very often where it's unnecessary replacement. So let's avoid that. Let's be better. Let's do our checks. Let's do our research. Let's read service information. Let's consider all the things that I talked about today. And hopefully it'll make your life a little bit easier the next time you run into a control module issue or perceived control module issue that's really being caused by something else. You're going to be able to make the right call. That's the goal here. So thanks for listening today. I really appreciate it. Let's get out there and start fixing the world one car at a time.